Prof, we can't hear you. I can't hear you. I don't know about the others.
Madam Pearl, is it okay? It doesn't matter if for the case of stagging, right? In the case of stagging, can you hear me?
I can hear you.
Can you
now.
all hear
I
me?
can hear you.
Yes, Prof, can get you
Yes,
now.
I can hear you.
When we were talking about
can't-
stagging, in stagging, we were using multiple models now. We're using different models. We use random forest, we use decision tree, we use logistic regression, right? You see, you cannot hear me.
I'm getting
I can hear you, Prof.
So we were using different models. So even the random forest that you were using as M1, M2, or you were using it as M2 or M1, that random forest can be tuned to know which best parameters to run the random forest with, right? Because the final data that you want to use to train the meta model with it, that data, the better the data, the more performant, the more accurate the meta model will be. You get it? So even the other models that you train and then use those models now to train the meta model, if those models are well trained and they can perform better, that's how the meta models will perform better, because it's the output of those models that you use as the training data as the input training data for the meta model. So you still have to train them. That's why I was telling you that you have to go and train all of those, train plus the meta model. In this our case, we're using XGBoost as our meta model. So it makes sense.
Okay, Prof, I understand.
Okay, today let's do something. Let's look at something different today. Let me know if you can hear me.
I can hear you.
I think I'm not sharing my screen, so I don't know why it's saying I cannot share my screen. Can I share whiteboard? Once the whiteboard pops up at your end, please let me know.
I can see the whiteboard.
Awesome. Okay, now today let's look at another algorithm. Oh, we are done with the ensemble technique. So this one today is a standalone algorithm. So it's not like it's part of the ensemble technique again. So we are done with the ensemble technique. So today we want to look at another algorithm which is called KNN, which stands for K nearest neighbor. K nearest neighbor. This algorithm is used mostly for classification, and also regression problems though, because it's not like it's only classification. You can also use it for regression problems. But we'll see the best use case for this particular algorithm. So now this is what happens, right, during k-nearest neighbor. How does this algorithm works? How does it work? Okay, assuming you have a data set like this. Let's say, let me cancel this. Let me just take, maybe let's say we want to look at, each salary, and then let's say insurance, whether somebody will be insured or not. Insurance. So let's say this is our target. Insurance is our target. This is k-nearest neighbor is a supervised, so it has a target. The supervised machine learning algo. So it has a target. So let's take that somebody's age and then the person's salary and then whether the insurance company will insure that person, yes or no. So let's just simulate the record. So let's say your age is 30 and your salary is 70K. Obviously, the insurance company will insure you because they will be advantage. Let's say you are now 70 years and your salary is 40K. Insurance company will look at you and say, no, this man will soon die. And then let's say you are 45 years and then your age is say 50. Let's just say the insurance company accept to insure you, right? So now when you look at this now, in this case now, when you want to assuming you have data like this and then you plot the features, which is age against salary, for example, right? You might get data points like this. You might get data points like this. So let's say like this, data points like this, something like this. Okay, now. So what happens with the k nearest neighbor algorithm is that once you bring your data during training, once you have your data during training, so you remember we used to have our data, our full data set. We used to have our full data set, which is 100%. So we'll split it into 80%, 20%, right? So what happens is that when you give this 80% to the k nearest neighbor algorithm, so your M1 or your M1, which is a k nearest neighbor algorithm. So when you give it this data, this 80% of your data during training, what does the algorithm do? What does the algorithm do? So we are looking at how that algorithm functions. So what the algorithm does during training is that it does nothing. Let me hear you all say it does nothing. It does not do anything. Did you understand?
No, Prof. I don't understand.
I said it did not do anything. If I say you did not do anything, what does it mean that you did not do anything? It means you did not do anything.
Means that no training took place.
For example, yes, nothing happened. So when you just give that data to the algorithm like that during training, it will just follow the data and sit. There's nothing like training. Now the real work now comes when you come to test that data. You understand? So assuming now that, okay, this is our feature. I don't even know why I made this thing in three groups. Let me assumably, you know what? Let me cancel some points here and then I use a different color. Okay. So let me see. Okay, now let me just come and melange some points here. And then let's have some points here. And so let's also get some melange here. Okay, let's say that black, let's say black is equals to the person being given insurance, yes. And then red equals to the person being given insurance, no. This is what we are saying. So let's assume that if you are black, if you end up in the black zone, this is the black zone. If you end up in the black zone, so I'm going to get a different color of pen. So if you end up in this black zone like this, that means you have insurance, yes, and you end up in the black zone, you have red zone, you have insurance loss. But for some reason, we see that there are some melanges, some points have gotten in here. This can be like outliers or, right? This can be like some outlier values that have now come here. Instead of them being falling into the right category, they are now falling out of the right category. So now let's look at what happens during testing. Now, when you come with your data during testing, what happens is that once you give that data to the k nearest neighbor algorithm, say, okay, now I've trained you, I've given you the data for training, it will just swallow the data and see. So now let's assume that you come and give let's say you come and give age 30, you come and now give age, say you now come and give age 35, salary 80,000, for example. So now what is going to happen to the algorithm now? So it will come down and say, okay, age is let's say age 35, assuming age 35 is somewhere here. Let's just say age 35 is somewhere here, and the salary 80k is somewhere here. So this is 80, and this is 35. So now when you plot this point, they will meet somewhere around here. For example, let's assume that they meet somewhere around here. This is during testing. You now come and say, okay, I've trained you with my data. So now this person that is coming, this new client that is coming, is of age 30, and the person's salary is 80,000. So is this person going to get insurance or not? How does the algorithm now classify or now predict whether that person is going to get insurance or not? So the algorithm starts by selecting, start by picking a value for k. K represents the number of neighbors that the algorithm is going to pick. And so if k is equals to 1, if k is equals to 1, then it uses something called the distance matrix. Distance matrix. All of you Google distance matrix, please. Distance matrix. All of you Google distance matrix in k nearest neighbor. I want you to all Google distance matrix in k nearest neighbor. You'll be seeing different distance matrices. You've seen the Euclidean, blah 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 blah. Sharp. Madame Constance, Madame Prudence, Madame PL, Dr. Tony. I don't know if some other people have come in. Madame Vandolin. Okay. Madame PL, what did you see?
I saw that it is a table that shows a pairwise distance between a set of points in a multi-dimensional space. It is commonly used in various
I think
fields
that
such as statistics, machine learning, bioinformatics, and clustering analysis. Something
they
like
did
that.
not give you different. They did not give you the different distance matrices. Who has seen those funny
There's
names like
Euclidean distance, Manhattan, affine Herming.
Manhattan, and some kind of funny name. Another one is Monyoski and some kind of names like that. Right? We'll see those formulas. We'll see how their formulas look like. But those are distance matrices. So what is going to happen is that using the distance matrix, the algorithm is going to calculate the distance of this point from this point. This is your point that you are plotting from this point. It's going to calculate the distance from this point. It's going to calculate the distance from all the points in your data. Do you understand? It's going to calculate the distance of this predicted point. From the point, this location, you calculate the distance to all other points that are in your data set. Remember, during training, when you get the data, it just swallowed the data. So now when you now bring your test data, now you now start calculating, just like we have here now, you now start calculating the distance between the test point and, remember, this is our test point, right? What do people? This is our test point. So we now start calculating. So if k is equals to 1, then if we look at here, and then we'll see that this small red here is going to be our that small red there was supposed to be our, so we see that red here, there was a certain red here. We'll see that this red was the closest point. Therefore means if the value of k is equals to 1, that means the prediction for that thing will be what? No. it will be no. Do you understand? Because why is it no? The closest point, I told you again, K means the number of neighbors. K equals to number of neighbors. Number of neighbors. Please don't forget. Number of neighbors. And how do you know the neighbor to your house? The neighbor to your house is the closest person to your house. And so when you select the value of K to be equal to 1, K is a hyperparameter that you have to twin. If you select your value of K to be equals to 1, that means it will look for the closest one neighbor to that algorithm, to that particular test point, and then consider the target of that closest point as the target of the test point. Dr. Tony, is it clear?
It's not, Prof. And sometimes when you say from this point to this point, I want to believe that you are showing something, but I don't see the strokes or what you are marking. So it makes it a bit difficult for me to understand. I don't know if you understand.
You know, I forgot that you are that. But are you seeing our test point? This is our test point, Dr. Tony. This big green that I'm highlighting like this. And how is it our test point? It's our test point because we said the test data that we want to test. We have had data. Then we have given the data to the k-nearest neighbor algorithm. So the algorithm has swallowed that data during training and just sit. Now, one client just jumps into the office, and then you people want to know whether that client is going to have insurance or not. Dr. Tony, are you with me? Dr. Tony, are you there?
Yes, I'm here.
Yeah. So the client just jumps into the office. After people have trained the algorithm with the data that has client's age, client salary, and then whether the client was either given insurance or not, you use that data and then train the algorithm. The algorithm just follow the data and sat down. So now, during testing, now when you want to test the algorithm or when you want to use the algorithm now, another client just jump in. Another client just jump in and say, hey, company, I want insurance. Now, whether you now say, okay, oh yeah, algorithm, are we going to give this client insurance, yes or no? So now, how does the algorithm do that? Algorithm will say, okay, oh yeah, what is the age of the client? The age is 35. How much money does the client earn? The client earns 80,000. So it just plots, and if you plot 85 against 30, you'll see that both they'll meet somewhere around here. So this will be our test point. Dr. Tony, can you see that? Can you see our test point?
Yes.
Okay.
It's better.
So now after saying that this is our test point, now that's our test point. So now the algorithm will now ask you, okay, how many neighbors do you want me to look at before classifying this person? You understand? How many neighbors do you want me to consider before classifying this person? Okay, we are saying that if you say that K means your number of neighbors, right? K is your number of neighbors. K is the number of neighbors that you have. And so if K is equals to 1, that means you are telling the algorithm that to classify this person, only look at one neighbor. Only look at one neighbor. And so the algorithm will now come and say, okay, I'm looking at only one neighbor. Using the distance matrix that we are talking about, it will calculate which neighbor is closest to the test point. And so if we come now, we'll notice that in this our illustration, this red and this test point, they are the closest point. Oh, Tony, do you agree with me? Because the distance between this point here is shorter than all the distance between this point and every other point here. Because it's normally, so it will calculate the distance between this test point and all the data points in the data, in the training data. It will calculate the distance between the test point and all the data points in the training data. So if your training data has 1 million records, it will calculate the test point, the distance from the test point to all the 1 million training records. And if k is equals to 1, that means the distance, the particular test data point that has the shortest distance, the target of that particular data point will be considered as the classification of that particular test record. Dr. Tony, is it clear?
Yes, it's getting clear.
And now look at the data that we have here. We said here that red means you did not get, the target for red is you did not get the insurance, and black means you got the insurance. So in this our case, if k is equals to 1, automatically that means the classification of that client will be that the client did not get insurance. Full stop. It's simple now.
Okay.
They just compared one neighbor, and the one neighbor said no insurance. So how do they say it's a so comes a so? Madam Pudes. How do they say it? It's a so comes a so. I don't know. Does it make sense?
Please, Prof. Hello, Prof.
Madam, for some reason your voice is cracking, but now I can hear you.
And to better say what I've understood, does it mean that they got in contact with just that? Because when you're showing the points like that, I'm not seeing the points. There is that red point that is very close to that green. To
Yes.
the green. Does it mean that it will use just that point as a reference, and that's why we're having the no?
Yes, if k is equals to 1, because you say use only 1 point. You said k is equals to 1, so it will take the 1 point that is closest.
Okay.
So now, you understand what I'm saying? Now, if k is equals to 2, if k is equals to 2 now, what will it do? Okay, it will check the next point. You say, okay, you are closest. So which one is the next closest point? Madam, tell me which one is the next closest point.
There is that black point that is below.
This one, right? This one. This one. This there was a black here, sorry. Wait. There was a black point here. There was one black point here, right? And so, according to what Madame Vandolin is saying, that means if k is equals to 2, we'll have this point, and this point. Is that correct?
Which point is Doc? Prof? I'm not seeing.
I've circled them. I've circled them in green, Dr. Tony. You might have to enlarge your screen. I've told you people that this is an interactive whiteboard. You can make it as big as whatever you want to be seen. And you have to be moving the thing. You have to be moving it. Make sure, are you seeing this place that I'm drawing there like this? You have to be able to see where I'm drawing. Are you seeing where I'm drawing? If you are not seeing it, that means you have to move your whiteboard.
No, I'm seeing where you are drawing, like where you have the 35 and 80 and all. What I'm saying is that sometimes, right, when you say from this point to this point, I don't get to see the strokes, like the signs of the point you are talking about. But there are times we do it. Yes,
this one that I've circled it in green like this. I'm using green now. This point, okay, let me cancel it. This is the point I'm referring to. If you look at where I am working now, I'm working here. I'm putting green on top of the points now. This is my test point, so I'm considering the 2 closest points to my test point, and you see that it will be this red and this black, because my k now is equals to 2, right? So I'm taking the 2 closest points because my k now is equals to 2. So now let's look at this one. Black says yes. Red says no. So Madame Vandolin, tell me, what will be the classification of that new client?
I don't know, because there's yes and there's no.
Madame Vandolin says she does not know. Oh yeah.
Yeah, I'm taking black, because this is in the domain of the black.
Okay, Madame Tess, what do you think is the answer? One neighbor says yes, another neighbor says no.
First
So what
of
is the
all,
Let
answer?
me
I
guess.
don't know what's
Let me
happening.
guess.
No, I'm feeling confused there because now I not hear what the age and the salary were.
Madam Pearl, you don't
Hello,
even
can
need to
you
know
hear
the
me?
age and the salary. I said,
Can you hear me?
if we consider,
Yeah.
Madam Pearl, are you hearing me? I don't know if you can hear me because maybe you
Yes,
are
I'm
lost
hearing you
because
now, Prof.
I'm saying that this is our test point, and we have considered k
Yes,
equals
65
to
and
2.
80.
We have
Mm-hmm.
considered k equals to 2, and then we have considered k
Yes.
equals to 2. That means we are considering two neighbors. And
Yes.
unfortunately for us, all the two neighbors close to our test point, one says yes and another neighbor says no because it's red and black. So the question is,
Yes.
if one neighbor says yes and another one says no, so what is going to be the final classification of the test point?
I don't know it. But
I want to guess.
Let's hear the guess.
but now no is
Maybe
closer. But it's not a problem. We don't have to add the neighbors like that.
if I'm guessing that, I'll say that we'll now look at the distances between the neighbors.
Okay, we'll look at the distances between the neighbors. Okay. Let's go to the court of appeal and appeal this case. So when you
I don't
have
know the
something like
distance.
that,
When we look at everything now and seeing that the other neighbors are black, it's another issue.
now let's go to the court of appeal now and see. When you have a situation like that, like this one now, like this, are you understanding? When you have a situation like this, it is called tie. Have you seen my screen? It is called a tie. Like both situations, they have tied. You understand?
Yes, Prof.
Okay,
Yes.
so we don't have a final answer yet. There's a tie. So now we go up to k equals to 3. Dr. Tony, if k equals to 3, Dr. Tony, look at the neighbors to our test point and tell me which points we are considering. K equals to 3.
Saying the one that will go for.
Are you talking about these points? If k equals to 3, which points are we having? Are we having these points like this?
So the
Is that
first
correct?
red one, yes, exactly.
So this will be the points that we are considering. And so when k equals to 2, we had what we call tie. So when k equals to 1, we had one, no. We had no, right? When k was 1, we had no. When k equals to 2, we had tie. When k equals to 3, what is the answer?
The answer is yes.
The answer is yes. So who does not know why the answer is yes?
How? Me, I don't know. I don't know why.
Okay, let's look at k equals to 3. How many neighbors does the test point have, Dr. Tony?
How many numbers? 3.
How many of them say yes and how many of them say no?
Oh, I see. 2, yes. 1, no. Oh, I see.
Automatically, you see why the answer is yes now.
Hmm.
Are you following?
Yeah.
Okay, now let's take now k equals to 4, Madam Prudence. If k equals to 4, what will be my test point? Madam Prudence, is Madam Prudence on the call? If k is equals to 4, if I want to consider 4 neighbors, how many blacks will I have and how many reds will I have?
2 blacks, 2 reds.
Okay, 2 blacks. Hey, Aru. I instead when I cancel the thing.
Bro, did
So
you
Madam
just say arrow now? Bro, that is Igbo language. Who is teaching Igbo language? Bro?
Dr. Tony, I'm getting closer. So now we see that when k equals to 4, we have 2 black, 2 red. So what's going to be the answer? Madam Prudence, tell me. What is going to be the answer?
Should I say it's a tie as we had for K equals to 2?
Yes.
Since we have
So
a
if
1
K-
red and 1, so we have equal.
If K equals to 4, we have tie. Is somebody seeing something? Madam Pay, tell me what you are seeing. Madam Constance, what are you seeing?
At the
When
even
K,
numbers,
you have sense.
this
The even
tie.
numbers give
even numbers.
tie. Yeah.
Mhm.
So that is one recommendation. One recommendation is that always make your value of K to be equals to odd. K should always be odd. It's good to be odd. It's not like it cannot be even. But we have just proven that K is good to be odd. Is that clear?
Yes, Prof.
Okay, good. So that's the K nearest neighbor algorithm. Oh yeah, let's say something. Now, can you imagine that? Now just imagine. Okay, now instead of bringing it this way, let me give the recommendation. So let me come down on a very clean place. Let's put. I want to write something like use case of KNN. Yeah. So this case we were using was for a classification situation. So if it is for a regression situation, when it takes the neighbors, it will sum them and calculate the average. That is just clear, right? That is just obvious, right? Because if you take K equals to 4, it will take the target for all the neighbors, sum them and divide by 4. That's obvious, right? And then that will be the target for the test value. That's straightforward, right? People are quiet. Does it not make sense?
It's okay.
It does from my end.
It does.
Okay, good. So now we are saying that use case, we are saying 1, we say classification problem, right? Classification problem.
Prof, sorry, before you go forward, so please give me typical examples, typical applications of examples of classification problems.
Whether a patient ends up with cancer, or yes or no. Whether you go and play football tomorrow, yes or no. Whether your wife will go to the market, yes or no. Whether you come from Nigeria, yes or no. There are a lot of them. As long as the target is not a number. Can you think of any prediction that you want to predict that the target is not a number, Dr. Tony? As long as the target is not a number. That's a classification problem. You might want to predict the city where somebody is coming from, and there are 10 different cities. That's a classification problem. There is this one we were working on for malaria diagnosis. So whether a slide is malaria positive, malaria negative, high parasitemia, low parasitemia, whatever, right? I know now. Hey, Dr. Tony, I know you understand. So all those are classification problems. Whether somebody is malaria positive or negative, if positive, high parasitemia, low parasitemia, what? Right? Those are classification problems. So regression problem, calculating the price of a house, calculating the interest on your business. Predicted interest, predicted house price, predicted car price, right? Can be anything. Predicted temperature. What's going to be the temperature tomorrow? But if you want to predict whether rain will fall, it becomes a classification problem. That's why when you look at your Meteo app, the app for it always says rainfall estimated at this percent, 90%, 10%. One, you understand? They don't say exactly that it will rain. They say 90% estimated that it is going to rain. But when they come to temperature, they are giving you a value, point final. This is the temperature. This is the predicted temperature, right? Okay. Now, I'm saying that you can use it for a classification problem, use it for a regression problem. Now, this my interest in this is in this third one. When you are training data is small. Can somebody explain to me why it's good to use this one when you're training data is small? I want to see the people who were listening to me when I was talking. Madam Pe, you are the youngest in the group, so your ear should be sharper than that of any other person. Why
Prof,
do you think
what
you'll
are
be
you
good?
asking?
Why do you think it will be good to use k-nearest neighbor when your training data is small? We talked about it now. Why? Did you people hear me say that during testing, when it takes this point, it's going to calculate the distance from this point to all the other points in the training data? You heard that?
Yeah.
And so imagine if your training data is huge, will you support the computing power?
No.
So you
Unless
see,
with the highest NVIDIA's
you're using NVIDIA GPUs, right?
Yeah.
So if your training data is too huge, it will not be easy to compute it will not be easy to handle the computing power. So this is always good when your training data is small, because there will be fewer number of records to calculate the distance against. And if you go and see the formula for calculating that for that distance matrix, if you see the formula, it's crazy, something like that, right? Is that clear? Does it make sense? So this is it. Can we do the practicals?
Yes, it makes sense from my.
Oh yeah, can we do the practicals?
Yes, sir.
I think we still have some time, right? Let's jump into the practical session. Okay, let me leave from here because I'm going to be needing my screen.
So, Prof, I have a question.
Dr. Tony, can you hear me? Sorry, I changed my source of sound. Can I know if you can hear me?
Yes, I can hear you. I wanted to
Okay,
even ask
awesome.
you a question.
Yes, please go ahead and ask the question.
Yeah. My question is, so when do you now know the number of neighbors to use, whether 1 or 2 or 3, or does it still boil down to hyperparameter tuning?
Yes, it's a very big hyperparameter, Dr. Tony. It's a very big hyperparameter, and as you see in our practical session, it's always good, like we said. The only recommendation is that always try to use a neighbor, a value of n that is even. Do you understand? Because
That's
it's
odd.
going that is odd, sorry.
That's odd.
Yeah, that is odd because it will reduce your chances of getting a die. So
Hmm.
that is the idea. So all of these things, that's why I told you hyperparameter tuning in machine learning. You can get a job in a machine learning engineer just because you know hyperparameter tuning. I'm serious. So when I give you people that assignment like that, I want you people to master the concept of tuning your parameters. And that's why I even take time and I'm explaining these concepts to you. I don't know if you understand what I'm saying. That's why I take my time and I'm explaining these mathematics and trying to solve this thing in the background for you. It's simply because I want you to understand the concept behind, so that when I'm telling you that change the value of K, don't be asking me that what is K. I don't know if you understand.
Yeah.
When we go to XGBoost and I start telling you that the learning rate is this, the value of gamma is this, the value of alpha is this, you know what those things are. Then the concept does not sound to your head like a mystery. That's how you become good at the job, because you are doing it and you understand what you are doing. You are not just acting like a robot. I mean, that's what most trainings out there will do. They will just come and write the code here and show you that if you want to train it's simple now. I can just come and show you how to train a data set using k-nearest neighbor. You understand what I'm saying? It's simple now. I'll just show you. That's what most trainings will do. But I think it's to me, to my own understanding, I think it's way more important when I spend time like this and I explain, because you can even go and use an AI model and tell it to write code for you to train your algorithm. It will write the code for you. But the question is, do you understand what that thing has written? That's the question. You do not understand. So that's why we spend time to explain these things, even though the mathematics is not favoring you and I. But we still try our best to make it clear, because we want you to actually understand the background. And then the people who went to school, they will say the modus operandi.
Another question.
Yes, Dr. Tony.
Yeah, please, this question, I know you've answered it before, but I guess I was not clarified. I didn't understand it very clearly. Me, I don't like manual work like that. So I want to ask again. Shebi, I can use grid search something to search automatically to get the best this thing for whatever I'm training, the best value.
Yes.
Instead of imputing it to one by one or whatever manual.
Yeah, and try. Yes, you can, but you need the computing power to be able to run that. The only challenge we had is because we don't have the computing power. You are using your computer. But if you are working within an environment, within a company, they have cloud servers where your performance will not be a problem for you. That thing that we ran, that took 17 hours on Madame Pearl's computer. If you are at work, you run it and you get the result in less than 5 minutes. Because because this is what they do at work. They actually have servers that are dedicated for training. You've not heard of it. There are servers that companies just go and spin up. I don't know if you have not done cloud computing, you might not understand what I'm saying. Companies just go and, okay, let me use the word, they just go and buy big computers in the cloud only for training. And after training, that is all.
Oh.
Yes, that is where the majority power of AI, like the problem to have AI is not this code that we are writing, Dr. Tony. That's why when you hear that China developed DeepSeek using was it 5 billion compared to OpenAI that used 40-something billion US, the money went into training, because you need to buy sophisticated hardware and GPU to be able to run those algorithms. Just imagine, just look at this k-nearest neighbor thing that we are talking about. Imagine that I have my training data has 1 million records. And you know, and we have agreed and we have said this in class that if you want your algorithm to work better, give it more data. That's just the truth. Don't mind, we are training algorithm here with 100 records. In real life practice, it's data. And when I say data, I mean, so I don't even know whether people understand this thing. Can you imagine how much data Google generates in a single day? Yet Gemini is not the best algorithm out there. That means it still needs more data. And every day ChatGPT is getting better. Why? Can you compare ChatGPT in those days of ChatGPT of today? The reason why that thing is getting better is because every day we use it and we feed it with data. Chaque jour, people are using it and giving it data. It keeps training itself and getting better. The more data, the better. It's just like you. If I teach you with enough information, that's how good you are. That's why if you want to go to school and be a medical doctor, they train you for 7 years. After the 7 years, you come out and make 5 additional years, just so that they make sure that they have taught you enough to be good. I don't know if you understand the concept, Dr. Tony.
Yeah, I mean, with this thing now that you are saying, now I understand why your guy Elon bought Twitter and bought his company, his AI company, acquired
Exactly.
Twitter because of data and
because of data, yes.
Live data, yeah.
And you hear that they keep building data centers to be able to support AI. Like the United States, they are in a massive energy search now because they are trying to develop energy that can sustain AI data centers. Because what are data centers? Data centers are places where computers are packed. All these sophisticated computers. Why is NVIDIA, if you hear about NVIDIA, why is NVIDIA becoming one of the top companies in the whole world out of nowhere? It's because they have produced hardware, they have chips that have the possibility to do multiple tasks at the same time, that run parallel, that can do multiple tasks at the same time, which is good for AI. It's simply because of all this work that we are doing, all this ordinary grid search that we do here with 4 dimensions. I'm telling you, from range 2 to 20. If it's in real life practice, do you know what that range will be? To be able to get the best performing parameters, it will be thousands of loops. And then when we ran that thing, it gave us 330-something thousand combinations, and your computer was freezing. So to answer your question, it's possible if you do it. That's even how they do it at work. It's not like if you do it, that's what is done. But then, for you to get the best combination, you need the computing to be able to run that. When I ran my own, it took 8 hours. I remember when I was...
Can you do it on Google Colab?
Yes, you can do it on Google Colab and you'll be better. But on Google Colab, let me show you something. If you go to Google Colab, you should do this. Let me spin off my Google Colab because there's this work I'm doing on Google Colab that I use it for. I'm using it to translate and transcribe documents. Boris. I developed a model on Google Colab. Where is the thing? Let me come to my home.
But what I'm seeing here is your folder. I'm not seeing your...
Yeah, this is it. This model, you see, audio transcribe dot this is my
Google. We can't see your screen. I see your video.
How can you say you are not seeing my screen? That I'm sharing my screen. Have you seen my screen?
Yeah, it's up now. It's up.
So when you go to, this is a model I developed. I'm using this model to translate and transcribe audio files, heavy audio files. So you see, this is the output of the file that has been transcribed. But when you come here, there's something you have to do here. The thing is even still loading. Let me this. Where is that listing now? Is it here? Change. Okay, you come to change runtime type, and then you come here. See, if you use CPU, you'll be using your RAM. But if you use GPU, you'll be using your graphic card. And this is what NVIDIA produces. That's why you hear they produce powerful GPU, not CPU. GPU are graphic cards. And if you are using Google Colab and you want it to perform better, run it on GPU, not CPU. Don't use this one will still work. It's not as it will not work, but it will be slower. So you have to use your GPU. And if your computer has a good graphic card, of course. So if you, sorry, yeah, but this should run directly from Google Colab GPU, because this one works better on GPU. So it will work directly on Google Space, because everyone should have this one now. You see, I'm using the T4 GPU. If you are using a more, if your account is paid, you should even have bigger GPUs here, and not this very tiny one that I have here. So if you are using Google Colab, you can use GPU like that. These
Okay,
are,
thank you.
yeah, these are tips, just stuff, but this thing is interesting. Let me tell you guys, this thing is really interesting. There are days that you go to work and you go back home smiling. You do like 1,000 jobs in 1,000 things in one day. That under
Wow.
normal circumstances, you would have spent your whole life. Massa. If I show you quantity of videos that I transcribe in less than 2 hours, you'll be shocked. Let me show you now. So you people need to learn this thing. You need to learn this thing. I'm just showing you people just to encourage you. These are audio files. This is somebody's research work. These ones are not even complete though. They are not even complete. These are some. They are more. I think they are in my downloads folder. They are in my downloads folder. I think I downloaded them and they are somewhere. Okay. These are, you see, these are more of them. I took less than 2 hours to transcribe all these files and translate them. Like transcribe and translate, oh. Not only like these are audios, like they are, and then they are even speaking in French. I don't understand French. So what I did was that I developed a model that took in the audios, transcribed the audios into text, and then convert the text into and then translated the text into English that I can understand, because now these are the text files. You see, these are the text files. And then after that, now I analyze the data. This is the analysis. You see, you analyze the data. At these many files like this, I combine them, then I run the analysis. You see, this is the analysis. This is the analysis. C should be managers. Who is manager? Healthcare manager. Maternity analysis of data. Maternity analysis. You see, this should be, yeah. You see, this is the analysis that I even did. And then all that data you have to categorize it, pick key points from audios, and then how many people said what you heard, pick the key points, you know, and then you did a word cloud. This is called a word cloud, right? Did the word cloud just to plot the data. You see, these things run fast. This is something that I remember in those days when we were still learning statistical programming using R. This thing will take you 2 weeks before you ever get close to something like it. In short, you will not, there was no way to even have, you would have been listening to these audios and writing. Can you imagine? Can you really imagine? You would have been listening to these audios, or you go and pay somebody to be listening to the audios and writing. When the person is done writing, maybe the person is writing with a pen before you go and type. Can you imagine? It's really crazy. The person is done writing, then right, you go and type. You type now and finish before. But if you understand how to do, and I use only the simple concept that we have been learning here to do these things. Are simple.
I was going to ask you what you use here.
It's just simple now. You look at the model that I'm telling you about here. SK, when I showed you that thing on Google Colab, was there any complicated thing there? Let me show you. You think there's anything here? You see pip install. Are you see? These are things that we have been doing. Pip install. This is this is just linking to the GitHub account, because this is the algorithm called Whisper. It's just that it's a specific algorithm by OpenAI that you use it for translation and transcription. So all I needed to do was run pip install and then pull the algorithm. This is it from their GitHub account. Once I do sudo update just to update. You people saw the other day I was struggling to update, right? I updated this thing. It has updated and it has run. And so I just come down here and I pass the command like we used to do. If I want to use pandas or I want to use numpy, I say numpy blah 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 blah. I just come here and I do whisper. That's the name of this thing. The same thing we're doing. Whisper, I pass the file, the name of the video the audio that I want to translate. When I say medium, it means that I don't want to use a large model. Medium means small. Medium, then there's medium, small, and very small. then you say your language that you want to translate. This is in French. So these are just parameters, just like we study now. When you create a function, it has parameters. So you just have to do these parameters. And just like we do shift tab on our this thing to see what those parameters do. If you do whisper help here, you see what each of these parameters is. The same thing that we do shift tab and they're explaining to us. This is the very thing. There's nothing here. Nothing here is new. The same way you go and do pip install sklearn and download a model online. So when you finish this thing, you come across any model. It's just that we cannot exhaust all the algorithms on earth now. There are plenty. There are plenty as well. But the principle is the same. If you finish the program, you go and see an algorithm. You want to do your thing online and you don't know how to do it. Just Google which algorithm can do this best. They would recommend the algorithm. If you need to install it, you install it. If it has been compiled and is ready for you to run, I mean, straightforward. Nothing here is out of the box. You pip install. We have been doing pip install all the time. You see, this is my installation process now. It's showing complete. So that somebody should not see these long lines of code and feel that I ran this, I copy. I did not write all these things. It's just that because I understand how these algorithms now work, I'll just know what to do when I get there. As simple as that. Because you go to the documentation, they'll tell you for you to use the algorithm, run pip. You already know how to run pip now. Pip install. They give you the URL. You pick it, run it, pop. And then if you want to update the algorithm, you update it if you want to. Their documentation will give you all this code. And now that because you have studied, when you see this thing now, at least it's not like you'll be completely blank. Now, when you start practicing or you start working, you start getting experience. That's how these things now begin to build up in you. But at least when you see it now, at least you know that this pip install in class, we used to use pip install to install packages that we don't have. At least you will not be completely blank. So if you see it in their documentation, you know what this means. And we've talked about GitHub. We had a complete session about Git. So if you see this thing and then see this URL, you know that what is happening is that this thing is going to these people's GitHub account to get this algorithm and installing it on your notebook. It's as simple as that. Sudo update to update. I mean, we've seen the other day now. You remember the day I was struggling, I was having issues with XGBoost. I told the people that I updated it. You just do update. Sudo means you are using your administrative powers. I mean, you might not learn all of these things at once, but the core concepts behind this thing are all there. Now, when you start practicing now, you start seeing that, or you start manage. Even me, I don't even manage. I don't know all of these things. When I needed this algorithm, when I needed to work with it, I went online. I was looking for it. They directed me to their documentation. I went and saw the documentation. I just followed the code there because I understood. Because when I read it and it gives me an idea of what it is, I just use it. As simple as that. AI is taking the world. Please, you people have to take these things serious. If your job. If you are not happy with the job you are doing, okay, they will come and take it from you. And you'll be crying. And again, it's not only about taking your job like people say it, right? It's about also using the thing to make money now. Who no like money? I beg. Because me, I do work. You need to put your head, even in your own job, whatever you are doing, whether you are a teacher, whether you are I don't know, whether you are a teacher or whatever, there are algorithms online and they will show you how to pre-run them and you customize them to do the work for you, right? Develop your notes. In short, I don't know. We are working on one of these ones from some people that, like I told you about the one that we were working on diagnosing malaria. If you're a medical laboratory scientist, do you need to go and sit down under the microscope and look at that thing again like that? Because the concept was just simple. You take pictures and convert them to arrays. We already know what arrays are because we study arrays under NumPy. Yes, you just take pictures and convert them to arrays because it's not like you take a picture and give it to a machine learning model that learn these pictures. No. There are already functions out there that convert pictures to arrays. And so you just take that picture and convert it to an array. We know what arrays are. We've done 2D, 3D, all of those things. We studied them. Those are arrays. You just take that picture, give it to There are already modules out there that convert pictures to arrays. When you see that array now, you understand what an array is. That becomes your training data. You use those arrays because for each picture, that array is going to be specific. You use those pictures, send it to a machine learning algorithm. That is all. That's your training data. And then when you now take the picture, by the time that you take the slide that a patient has come, you just take that slide and put it on a microscope, you snap it. Because there are already microscopes that come now, you put the slide, you see it on the screen. You just take a picture of it and send to the algorithm. The algorithm just decodes it directly and then it gives you a diagnosis with accuracy, saying that this thing is 95% correct. Do you even need to go and be looking at the slide again? I mean, things are changing, please. We need to be, you need to up your game. I'm serious. Whatever you are doing, begin to look at how to integrate this thing in what you are doing. Otherwise, okay, wait. Let's go back to K nearest neighbor. How many people are available to follow practically?
In total blackout, I will not follow practical. I can only follow on my phone.
Even me.
I will not be able to do the practical.
I'm in SWA and there's a match coming up and we are having blackout. Can you imagine everything? Who again will be able to follow? If nobody's.
I will.
Okay, awesome.
My machine has some light.
Okay, so let's get. Let me share the models in the libraries. Let me share the libraries in the chat. Somebody left the chat here. Okay, Dr. Tony, you were confessing that you have not done assignment. People, for the sake of information, Dr. Tony did not do assignment. We can just join all and say shame to him. Shame. Okay. Please, if you're following along, just pick the this thing from the chat. Let's just run through the practical section. So let's do shift enter. Okay. So now I don't know which data set I'm going to use. Maybe let's use the same idea of age and then salary and then whether somebody is getting insurance, yes or no. So what we are just going to do is that I'm going to create a variable called age, and it's just the same variable we have been creating. Age is equals to, let's use, there is this function.
Please, can I make a request? Can somebody help me? I'm putting it on the WhatsApp this thing so that I can copy.
What is wrong with your chat? Madam, that's Madam Prudence. Madam Prudence, your chat, you cannot get this thing from the chat.
And they will take me a long process. I already signed out from this thing in my machine, since I thought we'll be doing just.
Oh yeah. Yeah, somebody can be helping you and doing that. So let's say rand in, we are just creating an integer, okay? We use the random function in NumPy. So we are just creating random numbers. We want 20 of them in number, starting from 20 to 100. And we want 20 of them in number. So that's what we are doing. And maybe I have to NumPy dot random, there's this function say random dot seed, right? So because we don't want the numbers to change after we run them, so we can just put a funny, this one, you remember we did that random state equals to 42 like we always do. That's the same function here. That's what I used to always remind people, that random dot seed. This will stop this thing from generating random numbers after it has generated already. So we have age. And wow, run this. Somebody's trying to ask me a question. Yes, I'm talking. You cannot hear me. No.
Okay, your voice was really.
But is it okay now?
Yes.
I was just explaining this random state. like the same thing when we develop a model, we say random state equals to 42, so that when you develop those random numbers, they should not change. I'm using the same function here, random.seed, and I'm just passing in any funny integer, 10. It can be any number. And then I'm using the random.runIn function in NumPy, and I'm creating 20 records starting from 20 to 100. So that's why you see, if you count here, there will be 20 in number.
This
between
meeting
20
is
and
being
100.
recorded.
Okay, let's go. So I've created my each column. Let me say salary column. Madam, somebody needs to mute herself because the thing is just making noise. This is salary is equals to, I will not use the same numbers for salary because salary is supposed to be in thousands. Let's just say 15,000. 15,000 to 70,000 or so. Let's say our salary ends at 70,000, and we also want 20 records. So the random state is the same. So we run this. Okay, this is our salary. And so the next thing we need to do is that, do I need to be sharing this thing in the chat?
What's that?
The code that I'm writing, but you people are supposed to be writing your code too.
I think
So now we need to convert this to a data frame. Let's say the df equals to pd.data frame, and the data frame we are using a dictionary where we have age is age, comma, and then we have salary. Salary should be salary. There's no need. Salary should be salary, and that should be all. And then when we run df, we get a data frame with 20 records. Okay, this works. So what next? This is our data. Let's see the relationship between these data, like I was explaining, right? You remember that my funny plot that I was drawing? That my funny plot that I drew like this, where we plot salary against age. So let me draw a funny plot like that, so that we'll see how it looks like. So I would have ERT.scatter. Scatter is double T. And on the age, on the x-axis, we are using df of what? Age, right? We are running df of age, and on the y-axis, we want df of salary. Df of salary. And then we put a semicolon outside here just so we don't get some funny. Okay. So we have this, our drawing. This is our drawing. So when we are looking at this data now like this, so it's possible that our test record now can fall somewhere here. If our test record falls here, and so when we do k equals to 1, this is going to be the neighbor. If we do k equals to 2, now we'll calculate. Is it this one that is closer, or is it this one, or is it this one, or is it this one, or is it this one? It has to calculate the distance to all the points. Dr. Tony, is it making sense?
yes, well, please. Can we see the code?
Which
No,
of the
please,
codes?
no,
I've been sharing these ones in the group. I've been
data
sharing it
code.
in the chat, so you can just be picking. You can just be picking the code from the group chat. From not the group chat, though, not
The
WhatsApp.
library, I've joined on my machine, so I can't see the previous quote. Please,
Oh,
let me just copy.
let me share the libraries again. I don't have light, so we have to go fast before my computer go off. Yes, you people will complete this one so on your own. I'll share it again, and then if that is the case, let me share this other code again where I develop the age and the salary. Me, I'm a nice teacher. So I'm sharing code for you people. The time I'm learning this thing, you don't buy 2 screens and be typing and following. They will not tell you before you open your eye. They're telling you that will be all for today. See you in
Prof,
the
now
next
you're
class.
sharing the code when I've already written everything.
You see how I'm making our life sweet. Okay, so now we have plotted our data. So now the next thing we need to do is that we need to do what it's not like I planned this practical session. Let's create a target column, which is going to be the insurance column, right? Whether somebody gets insurance, yes or no. So yes is going to be 1 and no is going to be 0. So let's create a column called ZF of insurance, Abi. Insurance. ZF of insurance. And then ZF of insurance is equals to, let's say, ZF. Now, there's this thing, let me use. So this, you remember we talked about lambda functions. So let me use lambda. Let me use lambda x. Oh, sorry, lambda x. And we are saying that if x, this is what we want to do. If x is greater than or equals to 20, we are creating a column for the insurance. So we are grouping this based on the insurance. So we are saying that so we are using a lambda function, and we are saying that if x is greater than or equals to 20, right? Maybe let me wrap this so that I don't get it confused. So if x is greater than or equals to 20 and yes, Dr. Tony.
Please don't be annoying.
And
Can you
it's okay,
remind
Dr.
me
Tony, ask
what the
your question. That can I remind you of lambda function?
what is it again?
A lambda function, we said, is a function that you use it once and you don't need to use it again, right?
Come again.
A lambda function, we are saying that is a function that you use it once and you never have to use it again, right?
Yes.
So it's as simple as that. So we are creating a lambda function. We don't need to use it again. And we are using if else here. There's nothing here. It's just that we are writing this thing in one line because we are using a lambda function. So we are creating a lambda function and it takes a variable x. And we are saying that if x is greater than or equal to 20 and x is less than or equals to 40, then, and if you remember the lambda function, then that person will be insurance, yes, so I'll put 1 before. This is how the lambda function works. You write it behind. If it's true, you write it behind. It comes behind. But then else, if it's false, and then else, how do you do else now? Else, then it's 0. So we are saying that if the person's age is less than or equals to 20 and the person, so now we can use the age here because I'm thinking of using the age. So I have to explicitly use the person's age. So I have to use ZF of the person's, I'm writing age. I have to use the person's age, then the person's age, then dot. I use the apply function, and then I pass this inside quotes like that. That's how it should work now. Mhm. And maybe I group these ones like this just so the else part. So this should give us. So what we are saying here is that if somebody's age, if in the data that we have called DF, if the age is greater than 20 and less than 40, and then that person will be given insurance. If not, the person will not be given insurance. So maybe our determining factor for insurance is just age. But remember, we have age and salary, okay? And so once we do this, we now check DF to see what we have. Okay, we have the insurance column here where we have 10101010. Okay. Let me share this in the chat. Don't want anybody swearing after me today. I'll try. Okay. Madam Prudence, has anybody chosen to help you or they let you
Yes,
suffer
Prof.
alone?
I'm okay. I've gone back with to my computer, so I'm getting there.
So you are following along?
Yes, Prof.
Dr. Tony, you uncle?
Yes, I'm feeling along.
Okay. So we've created so this is the data we are going to use in for our key nearest neighbor, at least for the sake of peace. So now let's do a funny plot to see what we have. So let's do SNS dot there's this, we call it a real plot. And then we see in this we have x is equals to h, and then comma y is equals to, we already know that salary, and then data is equals to df, and then hue, there's something called, I don't know how do they pronounce this word, my English people, hue is equals to insurance. So let's run this. No. Could not interpret salary for why? Oh lolo, what did I write? Salary. Oh Boris, salary. Oh, salary. People are also now looking at me, Madam Constance, and you are looking at me suffer. You are not nice. I'll just unfriend you.
Sorry, Prof.
Nah, don't tell me sorry. You watch me suffer. Okay. Do I need to share this?
Yes, please.
Okay, I just dropped it. Now let's look at this data. Please, if you are 1 minute, all of you type and check your heads up. Type, and lift your heads up. And if I catch you now, you could die. Are you there? Please, I want you to pay attention. Let me show you something. This thing, this way should not discourage, should not confuse you. This is a legend. So don't consider it at some point that I've been plotted. This is a legend. Hey, Dr. Tony.
Yes.
This is just the legend. So it should not confuse you. So if you notice this point, all this yellow, which is 1, that means insurance, yes. They are all on this side. Can you see it? So I can put a decision boundary here. And I've separated my data into 2 groups. So this data is linearly separable, right? And that is also one of the applications of k-nearest neighbor. You can use it for data that is not linearly separable. Data that is not linearly separable is data that, let's say you have different points like this mixed up, you have different points like you cannot actually draw a decision boundary in between these points to separate them into two different points, right? Like I cannot separate the zeros from the x. This data is not linearly separable. But this data is linearly separable because if I put a decision boundary here like this, I would have separated all this way. I'll have all the yes, and here I'll have all the no's. As you can see, that's why I was telling you that don't get confused because this is just a legend. Don't consider this one as part of the one this way because it's just showing a legend. So that's one of the applications of k-nearest neighbor. It's used for data that's not linearly separable. Okay. So we have drawn our funny curve. Okay, I want us to do something. Let's hack this data. Let's make it not linearly separable. So we are going to, it's not easy, but what we can do is that we are going to pick a point and then hack that point and change the value. Which point? Should we take this point?
Okay.
Let's change that point. So if I have to change that point, I'm seeing salary is somewhere around
50,000.
salary is somewhere around 50,000 and the person is around age. The age is around 60, something between 65 to 60, around 65, 67, 65. So let's go up into the data and see which record has been plotted here. And then the person ended up no. So 65. We had something around 69, right? Was it 69? No, it was not. It was not that close.
Fifth.
And then the salary was 50,000. The age is 60 something. 60 something. Where are the 60 something? My people, you're not helping me. I'm
60. This 61.
here. 60
and 52,000.
Right.
Insurance.
I don't know if it's from my network. I was not hearing clearly.
I thought it was my own network.
Yes. Okay.
He's a teacher. I hope that his computer has not gone off. I don't have light.
Wow, our own since 2 days. And I live in the city.
Network like this. Let me know if you can hear me. Hey, my computer is running down.
We can hear you. We lost you for a while.
We lost you.
Can you hear? Can anybody hear me, please?
It's now that we are getting you. We lost you for some minutes.
Can I get confirmation that you can hear me or I'm alone?
Yes,
I can hear you.
Yes, we can hear you.
Can you all hear me?
Yes, Prof, I can hear you.
Okay. So let's hack let's hack that point. Let's hack that point. Let's quickly hack that point.
I'm not seeing your
And
screen, Prof.
and see what we can do about it. I'm sharing my screen.
Okay.
Oh, yeah.
Graph.
The class wants us not to continue so that all of us can participate next class.
Village
Some
people.
of us are already off blackout.
It's almost.
Sorry, my network is now messing up with me. But I'm sharing my screen now. I don't know if you can see my screen. Can anyone hear me?
Yes, you
Yes.
can hear, Prof.
Okay. We're trying to hack a point. Sorry. So let's see. What do I think?
Bro, that is like around H60.
Pardon.
I said that want to have. It's like it's around H60.
There, it's around this. It's around. Let's just take this one. Let's just pick this one. So we see that it's normally no, by default is no. So we can explicitly change it to yes, right? The index is 8, so we can explicitly say df dot log, and then we have the index is 8, right? And then the column is insurance. So we can change the insurance to, so instead of, so we can change it to 1 instead of 0. So once we do that, and then we get df, then we can see that that 8 has changed to 1 now instead of 0. You see up here, it was initially 0. So we have changed it now to 1. So if we plot this curve back, we'll see that it will be up, that one now will be yellow. So so if I run this back, You see that point has been changed to yellow. So now to draw a decision boundary across these points now will not be easy now. You have to draw like this. And then you have to do like this. Right? At least it's not like that straightforward like it was before. So let's just use that point as our reference point, okay? Are we clear on that?
Okay. Please, let's see the code.
Pardon?
The code.
I did not do any code. I just repeated the same one I plotted above. Maybe you are talking about this one.
The manipulation.
Yes.
It's just this one. I just used lock to pick the index and change it. Are we okay? Now we are good. So the next thing now is that at least we have made the data somehow funny. So let's segregate the data into segregate the data into features and targets. So x is equals to df dot wrap and columns is equals to insurance. So that's my target, and my y is equals to df of insurance. So if I run this, why is it taking long to run? Oh shit. Insurance. Okay, so if I run y.shape, if I run x.shape, should have 20 records. Okay, good. So that is it for the data. Now, something is not right here because if you look at this salary is in thousands and each is in units, just 10. So we need to scale this data. So I think we imported standard scaler up here, right? So we'll have to do st equals to standard scaler as a function. And then we do x scaled because we want to scale, but the x variable x scaled will be equals to st dot fit. And what are we fitting x into that? Because that's the variable we want to scale. And so if we print x scaled, wonderful. S scaled is supposed to be anyways. But x scaled was supposed to work. I was expecting to see just a variable there. st.fit x. Okay, let's say x underscore train. No, this thing is fit transform. I think that's why my SQL did not work. Fit transform, fit underscore transform, because I wonder why the thing no work now. So if I run this now, I should have this thing. It should have been scaled. You see now that all of them now are in one unit. This column is for age, and then this one is for salary. So now, I don't know, maybe you people are looking for this code. So now that that has happened, I can effectively say x underscore train, comma x underscore test, comma y underscore train, comma y underscore test should be equals to train underscore test underscore split. And then what am I splitting? So this time around, instead, don't go and make a mistake and split x, because we are now splitting x scaled, comma y, and then we have our test size, test underscore size is equals to 0.2, and then we have our random underscore state is equals to, say, let's go back to our 42. And so if I run this, if I print x underscore train dot shape, if I print this, and then I print y underscore train dot shape, this should give me 16.2. Okay, it makes sense. So the test records will be 3. So if I do print, maybe I'll just copy from above. If I just copy and paste, so instead of train here, I'll have test. Here I'll have test. Okay, 4 and 2. Wait. Okay, yeah, 4 and 2 makes sense. Okay, awesome. We are good. So now we can feed our we can feed our model now. So let's do model. So k-nearest neighbor classifier should be equals to, I'm sure we imported k-nearest neighbor up here. Yes, this is it. So I'm going to pick it, and I'll come down and I'll call the function, and then I'll do knc.feed. Now what am I fitting? So I'm going to say I'm fitting x train, comma y underscore train. And if I run this, okay, the training, we said nothing even happens during training. The guy only swallows the data. So let's try to run a test. So let's say ypred, y underscore pred should be equals to knc.predict. And what is it predicting? It's predicting s underscore test. And so when we run, so let me just run this, okay? Let me run ypred so that we can see the accuracy ourselves. You see, it says 011, but if we run ytest, if I run ytest, so that we see the difference, it says 1001. So you see the first classification is wrong. The actual is 1, but what the algorithm has predicted is 0. Madam Constance, tell me that you can see that too.
I don't understand.
I can see it, but I don't really understand too.
We have predicted something now. We just predicted. But our actual value, you remember up here we have y equals to the actual value, this actual insurance here. The actual insurance, we said y is equals to df of insurance. This is it. df of insurance. And so we came down and then we are splitting the data into train and test. And then we said you should split that y and give 20% of that y and keep it as test data. So it will take 20% of these actual values and keep them as test data. And the 20% corresponds to 4 records. That's why when I print the shape of y test, it says 4 records. And what are the 4 records? The 4 records are 1, 0, 0, 1. And so now the corresponding test X record, the corresponding features for this record, I've told the algorithm to predict their value for insurance. The algorithm has predicted and said the first record is going to be not given insurance, but according to the actual data, it was given insurance. And then these other ones have fallen in place because this one says no, no, and yes, and the algorithm has predicted as no, no, yes. So let's measure the accuracy now. Accuracy, we are just comparing the predicted value to the actual values. So we say accuracy underscore score, accuracy score, and so we are just using y underscore test. We are comparing y test to y pret. My people, these are things that we do every day. It says it's 75%, so your performance is 75%. So now let's see how to do an actual classification, right? Let's see how to do an actual classification. So to do an actual classification, now let's go. Let's see how we can play around with the value of k. And if I come here, see, if I do shift tab here, you see that number of neighbors, n neighbors by default is 5. Dr. Tony, did you see that?
Yes.
So it's 5, but there are other parameters that you can play around with. So that's the value of k. So let's go up now and see how we can do a reclassification. Okay, let's come back to this record. Where's that record that we tweaked?
But
The H was 60. Yes.
Can you allow us catch up with you on the code?
I
Maybe
don't
you
know
can
where you are.
send it to
Prof.
All these things, the only code that I can share for you is this one. There's nothing here to check. I was just checking how many records are there. I mean, Dr. Tony.
Yeah,
and
that's
this one, maybe the X train, Y train. Yes, Madam Constance, you have a question.
I saw something when you were showing us the parameters. Please, can we go back there?
Mm-hmm. Yeah, sure. Shift tab. You are here.
Okay, I've
You're
seen
looking
the
at
metrics.
Minkowski.
At the beginning of the
the
class, you
matrix
asked
is
us to check the distance, the matrix distance, but this one has
yeah.
already given us a particular type. Does it mean that this is the
Yes,
default?
yes, this is the default, so you can change it to Euclidean if you like. But by default, this is Minkowski. So if you go to while we are waiting for the other people to type, if you go to k nearest neighbor, let's just go to their website, KNN, k nearest neighbor algorithm. No, let's not use Wikipedia. Let's use Elastic. Maybe let's use sklearn directly. Let's go to the sklearn documentation. You see there that you are having Minkowski there, Minkowski. And you can see the formula of the Minkowski here. Wait, let this thing open. My internet is not the best. I can show you the formula of Minkowski. How Minkowski is working. So that you know Quizzkey works. For some reason, the thing is not loading me the website though. Madam Pearl, I know that you have loaded the website. Can you tell us what you're seeing there? Huh? Then you just slow as if small thing now, they do shakara. The thing is slow as if we are now begging it to open up. This is serious stuff. Oh. Yeah. Is this the website that we have opened? Wonderful, this thing. Are you sure you have no crease like that? Open on a new tab, I beg. Small thing that I want to show now, network will not let me show you people. And the thing I want to show you guys was that if you open and go to the documentation, you'll see that there are multiple matrices there that you can use, but network is just messing up with me. Let's leave it. The year it will open, it should open. And let's continue. Okay, let's continue. This was the value we tweaked. Okay, so we have 60 and 1. Okay, now let's do 61. Let's do 61 and so you see this value is 60, right? 60, and then the price is 5, 2, 5, 9, 7. So I'll deliberately create a neighbor that is closer to this one, and then I use k equals to 1 to see whether it will use the same prediction as this value. See, are you seeing what I'm saying? I want to use this value, right? So I'll deliberately create a neighbor. Instead of 60, I'll put 61, and then this value, instead of 597, I'll use 598, for example. That means if I come down, this point should be plotted somewhere close. I'm using this point because we can identify this point on our plot. So I'm expecting the value to be somewhere around here, very close to this point. And then when I use k equals to 1, I'm expecting that it should give me the prediction of this point because k equals 1. That is the closest neighbor. Let's try. Oh yeah, look at me. So what I'm going to do is that I'm going to highlight this. Madam Constant, tell me that you do not understand. Madam Prudence, do you understand what I said?
No. Yeah, I did not
You do
understand.
not understand.
Prof, I did not understand. But before that, I'm going to copy your code.
Okay, let's continue. So we we want to do something, and so we want to, so what I'm going to do is that prediction, let's call this prediction. So we want to predict the age of somebody who is, the person is going to be 61 years old and the person has a salary of,
Prof, are you
the
sharing
person is
this?
61. This network is just making me discouraged now. So I'm saying that we want to predict whether somebody who is of age, we want to predict whether somebody who is of age 61 and earns a salary of 52598 is going to be yes or insurance no. The reason why I'm picking that point is because I know this point. Sorry guys for the constant knockout. I was saying that I want to predict the age of someone who is 61. I want to predict whether someone who is 61 and earning a salary of 52598 is going to either be yes or no. And the reason why we chose this value is because we know this point on our plot. And we know the prediction of this point. So if we come down on our plot, this is that point. This is that point. This is the point 60.52597. So the point 61.52597.598 should be slightly in front and then slightly above. So it should be somewhere around here. Dr. Tony, do you agree with me?
Yes.
So if we select K equals to 1, who will be the neighbor? This person, right?
Yes.
Based on our training data. If we select K equals 1, then this should be the neighbor. So we expect that when we do prediction for this person, we should get what? 1. Because yellow says 1, right? Because that's the closest neighbor based on our theory. Is that true, Dr. Tony?
Yes.
Okay, so let's try it out. So what I'm just going to do is that I'm just going to write knc.predict, and predict is a function. I'm just going to put a 2D here, and I'm going to put 61, and then comma, let me copy that value and just change it from, instead of 97, I'll change it to 98. So it's a different value. And then I change it to 98. Okay. So if I predict this, you see, instead of saying it says no, you see, it says no. So the question is, why is it saying no? The reason why it's saying no is because we scaled this data. So we have not scaled these values. So to scale these values again, remember the formula for standard scalar. Formula for standard scalar. Formula for standard scalar. The formula for standard scalar says the scaled value is the value minus the mean divided by the standard deviation, right? That's the formula for the standard scalar. I say the value minus the mean divided by the mean of the column divided by the standard deviation. And so if that is what we are doing, then we have to come back and we say that the h underscore test, which is the h we want to predict, no, not test, but say the h predict should be equals to, we want to scale this 61. So to scale that 61, we have 61 minus the mean h, zf of h dot mean minus the mean h, all this divided by, so can I just put this here so that it doesn't create confusion? All this divided by the standard deviation, which will be the standard deviation of h. The standard deviation of h dot SDD. This is the standard deviation. And so when you do this and then you run the predicted h, this is the scaled h. So we have to do the same for the scaled salary. So this one should be salary predicted. So salary predicted. So we are going to have salary here, salary, and we are going to have salary here. So if we run this will be our scaled salary value. And now that we know this value now, we can now come up and run k predict now. KNC dot predict, and instead of putting 60 and 61 and this, we can just take the h predict and the salary predict. So if we put that here and run this, oh, it still gives us 0. Oh, why did it not give us 1? Oh, so got in heaven. Sorry, my value of k was equals to 5. My value of k by default is 5, so that's why it's giving us 0. So we have to now see. So now, so let me see. So if k equals to 1, 5, it will give us 0. K equals to 1 now. Let's use k equals to 1. So if k equals to 1 now, let's change the value of k. Where's that thing? So let's change the algorithm. So I'm going to shift tab here and change this to 1. So I'm changing the value of k to 1. And so I'm going to run this again. So you see, it says it's using the neighbors as 1. And so if it's using the neighbors as 1, then I can now run this again. Okay, nearest neighbor predict age, salary predict. It's still giving me 0. Why will we still give me 0? I was expecting a 1, right? So I've trained it with k equals to 0, train feed, and then KNC dot predict H predict. Let me run this again. Let me just see. But it's supposed to use the same value, like for real, bro. KNC dot predict. Like it's supposed to just use the same values, like roughly the same values. Like, yeah, it's supposed to just use these values directly. So we were supposed to have it do 1. Still predicts 0. So are you sure the closest neighbor to this thing would have been this? Oh yeah, damn. You know, we are looking at it from this point. So if we now look at it from here, look at this value. What is that value? Oh boys. So let me convert this one to data frame, please. I want to show you something. Let me call it df1 is equals to df1 equals to pd dot, oh shit. You know, I was doing the wrong reference. Data frame x scaled. Oh, no variable called x scaled. And then if I return df1, because I want to have the scale data. So this is the x value, this is the distinct value. So if I get that point, so the reason why it's giving us 0 is because after you plot this point like this, definitely this point will not still be here. This point will not still be this point that we're picking, because when you scale it, the values change now. It's not still 60, this thing that I was looking at. So if I append the, so let me say df1 of, let me add insurance to this insurance. df1 of insurance should be equals to df of insurance. Yeah, should be equals, but I call df of insurance y, so why am I even wasting my time? So if I take df1, okay, now this is it. So now what we have to do is that we have to look at that value and then compare the neighbor. So what is the value? What value did we have for? -2. H is 0.078. So let's look for 0.07, 0.07, 0.07, 0.078. So it's somewhere around here, right? It should be some, why am I looking at it then? 0.07 should be, this is 0.06, this is 0.09. So 0.07 should be in between these two. This for H. Is that correct? Nobody is responding. Am I on the call alone? Our scaled value, the scaled value for the H that we picked an H of 61 and the predict and the salary of 52, but we needed to scale this so that it should be in the same scale. So after scaling it, we have the scaled value for the H being 0.0784, blah, 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 all this long thing. And then the scaled value for the salary being -2.929, blah, 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 blah. So if you come down here, you want to look at where that H falls. That H we say is 0.7 is in between 0.9 and 0.6. Is that not correct? Madam Constance, is what I'm saying correct? She's not even on the call again. Madame Pearl, is what I'm saying correct? Oh, maybe I'm here alone. No? Trust me, if somebody's speaking, I cannot hear anybody. Yes, Dr. Tony.
I can
Pardon.
hear, but I don't know if I understand.
Pardon, I can't hear you. Your double systems are they are echoing. So can you mute one and talk from one, and then kill the volume from one and use only the volume from one? Dr. Tony, can I hear you now?
Is it better now?
Yes, it's okay now. It's okay now. What were you saying?
Yeah, I'm just trying to say that I can hear, but I don't think I understand the last thing that.
Forget all these jargons that we have done all here. Because normal, you just use standard scaler to scale your data, right? Just like we did over here to scale the data. You remember the scaling now is to put the data in the same units. Your salary was in thousands and your age is in tens. I've told you this in class. If you train your algorithm with that, the salary will overshadow the age, right? You understand what I'm saying? So we need to scale that data so that both of them can be at the same scale. The formula for scale is what I just Googled, where you have is the value minus the mean of that variable divided by the standard deviation. That's all I've done here. So forget that thing that I'm writing, but focus on the intuition. The H was 61, but our algorithm during training never saw anything at 61 and 52,599 and 98. It never saw this kind of values because we had scaled the values. So there was no way you can come and want to test it and then you are using these values after you scaled it and the algorithm did not see, because there was no value during training. Remember, we have used X scaled as our data. Look, we are using X scaled to train our data because I'm saying X train, X test. I'm using X scaled to split it into train and test. That means I'm using these values like this. These funny values, not the 6, not this one, not this one. I've not used this data because it's this data that I have scaled. And after scaling the data now, I now use the scaled data to train the algorithm. So the algorithm never saw any age that is 60 and with a salary of 50 something thousand. So if you give that kind of value to that algorithm, it's going to behave wrongly. And now, so that means if we want to test somebody who is of age 60 and earning a salary of 59,000, blah, 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 we need to also scale these values to be at the same scale like the data that we used to train the algorithm. And that is what I did here. And the new scaled age is what I've called age predict. And the value now is, instead of 61, is now 0.7. And then the salary predict, instead of 52,598, is now minus 2.9298544444, blah, blah, blah. So this is what I've done. And now I'm predicting this. And so these are the values I want to predict now. So I'll predict these values. I'll say, okay, this is my salary, this is my age, and this is my salary. Predict whether the person is going to have insurance, yes or no. Is predicting insurance? Yes. Is it predicting insurance? No, sorry. And I was surprised because it's predicting insurance no. And I was like, why is it predicting insurance no? Because initially I was looking at the original data because my person was 61 years old and 52.597 after being scaled. And then, so I was expecting it to pick one and not that one. But I forgot that after scaling the data, it is not the same thing again. So I have to be using but the scaled values now to reference my prediction. And so I'm looking at my scaled age. My scaled age here says my scaled age is, where is scaled age there? What just happened? Did something by default disappear? Okay, my scaled age is this. This is my scaled age. So I'm looking at my data and I'm asking myself, where is my scaled age? And if I look at this scaled age is 0.07. So I'm looking for 0.07 on this thing. 0.07. I was even looking 0.07, 0.01, 0.0, 0.0, 0.07. This is 0.04, right? So 0.04 and 0. So if you look at this value, you'll notice that 0.07 should be somewhere around this neighborhood here. It should be here. And all the predictions here are 0. So all the neighbors are zeros. So that's why the algorithm is predicting 0. Look, after predicting this value, I get the insurance output as 0 because it's considering the closest neighbor. And if you look at the salary says minus 50 something. So you see around the neighborhood minus 2. So around the neighborhood of minus 1, right? So you see that the thing is around this neighborhood. And every value around this neighborhood is 0. So it cannot predict another neighbor that is not in its neighborhood. Does it make sense? If it doesn't make sense, you might have to go and sleep and then digest it and watch it again. Or you ask me a question. Otherwise, I don't know what I can explain again.
As well. So, Prof, is this last part now? You know, you were checking.
Yeah, I was just testing now. Yeah, I was just testing to see if I want to predict something to see whether the algorithm is working the way I expect, right? So I say, okay, fine. Let me get a value and then predict, and then knowing the neighbor of that value. So let's get, for example, let's take H. Let's take H, for example. What was the H? The H is 0.07, right? Dr. Tony, 0.07 is our H.
0.07.
What is the closest value here to 0.07 in the H column? Let's look. This is 0.6, 0.4, 0.9, 0.03. Let's see. Do we have 0.07, 0.6? So 0.03 is here. So this is 0.03. Look, this is 0.03. Are you seeing 0.03 here? So 0.07 it will be around this neighborhood. And if you look critically, it can be here, somewhere around here. And if you calculate the neighbor, this is another neighbor here that is 0. Because we are using k equals to 1. Right? So it's taking the closest neighbor to it.
Okay.
So we don't know whether 0, because we have not sorted this data. It's not as if it's sorted, right? It's just calculating the distance. And we are just using that rationale to calculate the distance. What's the distance? Because this one will be closest to 0.07 than any other value on this table. This one is 0.6, not 0.0. This is 0.6, not 0.0. So we are looking at something like 0.0. So 0.0, where is 0.0 on the H column? The only value with 0.0 is this 8 value. And it even this even our reference value. And if you look at the value here, it says 1. But then our value now falls a bit down. So if you calculate the difference between the two values, if you calculate the distance on the plot, definitely it's now predicting what? 0. Because 0 is one of the neighbors. So you calculate
so the prediction now is 0.
So it has surely picked but this value now as its predicted value because it will be the closest neighbor if k equals to 1.
Okay.
So now if you calculate k equals to 2 now, it will take maybe this one. It will be a tie. So if you calculate k equals to 3, maybe it will be this. Then it will be 1. Let's try k equals to 3 and see what we get. So I'm going to try k equals to 3. Right? K equals to 3. So I'm going to run this. So my k equals to 3 now. Can I predict it? If I run this, it still gives me a 0. So k equals to 3 now. I don't know which values it's now looking at, but it will now be calculating around the neighborhood of it's either calculating somewhere around here like this, or somewhere around here, I don't know, wherever it's picking, or somewhere around here like this. So it just picks the majority. So that's how the algorithm works. Any questions?
Okay.
Any questions?
Oh,
Okay,
today's
in the absence of any question, let's leave it here for today. And then I'll see you all in our next class, which is coming up on Thursday.
Thank you.
Okay, bye-bye.